Hey there, viewers. Welcome to the Daily Space Weather. You may have noticed some interesting activity happening yesterday. We streamed it live on the Twitch channel at the Smash News Network, least busted name in news, and thanks for tuning in. Congratulations on realizing the channel exists. So, a huge filamentary eruption known as a coronal mass ejection occurred yesterday, starting around 1600 Universal Time. And we were streaming it. And, there was definitely a significant coronal mass ejection associated. It's got an ultra-dense core. There you go. I mean, talk about some spectacular CME activity. So we've just put together, that's just 6 hours there, 1600 through 2200 yesterday. That is March 11th. Here's a further zoomed out series of images there. That CME does not appear to be earthly directed, but you might be able to see another one happening up here. Is that earthly directed? We'll let you know that and lots more on today's Sunday edition of Daily Space Weather, and we've got an inordinate amount of solar imagery today, so probably something like 100 tabs open, so fasten your safety belts. It's going to be a long and bumpy road. Yeah, so great times for space weather right now. Of course, we've got multiple wavelengths, as you may have come to expect from the channel. And we've seen actually a reduction of solar activity happening since yesterday. A bit of a downtick there. It'll have people all frightened that the sun is shutting down and things like that because of propaganda on YouTube, primarily, I suppose. Here's 171 angstroms, our house favorite wavelength. Let's allow that to play through one more time there. And by the way, if you haven't visited the links below the video, check them out. We've got a Redbubble shop. We've got 32 designs there at this point. And thanks to everybody who's picked up merch and helped to support the channel that way. We greatly appreciate all of those contributions as we are contributing to science ourselves. And of course, this design is just so over the top. We just love it. Croissant Earth. Make sure you become a member of the Croissant Earth Society, folks. And stop believing NASA's lies. Of course, we are making fun of conspiratards on YouTube with this. But it's a great conversation starter. Of course, I think we've made some people angry as they actually think that we think that Earth is shaped like the French breakfast pastry. Croissant Earth Society. I think it's just great. And so you can support the channel with clicks also. So make sure you see the homepage, smashomash.com. You can find us all over social media at smashomash. And thanks to everybody who has clicked. If you're unable or unwilling to open your cobweb-encrusted wallet and support the channel directly, support the channel via clicks. Lots of links below the video. Press like, subscribe, share, etc. Tell your friends and foes about us. We are unconvinced that YouTube recommends the content. For some odd reason. Not sure why. Anyway, here's some more imagery, and let's reload that because it's flashing annoyingly. Also the magnetogram. So give that a minute to load there, folks. We want to show you the SDO intensitygram and SDO colorized magnetogram. So there's your intensitygram, and again, we've seen actually a reduction of sunspots here. We've seen some sunspots appear and then evaporate just as quickly, like this little group down here. And yeah, we've seen a decrease in solar activity since yesterday. Some folks will be proclaiming that as a grand solar minimum for some reason, even though you would need multiple very weak solar cycles in a row, something that we simply aren't seeing. So anyway, there's your SDO intensitygram. Let's switch to the magnetogram. There's your colorized magnetogram. a significant downtick since yesterday's space weather video, and don't worry, we've got lots more images here of the closest star. Thanks for stargazing with us here at the Smash News Network, least busted name in news. So this is a great wavelength to view a lot of variation in the solar corona. 211 angstroms shows the extended corona, 171 angstroms shows the lower corona, and a result of that, you get great absorption features there showing up as dark regions. You can also see coronal holes like this one here and this one down here in the southeast. We've got a series of small prominences there around the north heliographic polar region. Figured we would show you some of those before we go around the horn. So let's take a look at the greater northwestern limb. And those, my friends, are some sweet images from SDO. Here's your southeastern limb. These are all 24-hour videos, by the way. We started out with shorter ones there, just showing you the CME event, the coronal mass ejection, where huge portions of the solar corona are flung out into space, defying gravity and obeying magnetic fields. Here's your southeastern limb. Looks like there may be another active region rising there. And huge filaments up here in the northeastern limb. So our viewers have named some of these. This rising one up here, as well as this one up here, were named yesterday on Twitter. If you want to name filaments after living people, just join us over on Twitter at SmashOmash and follow the hashtag #NameThatFilament. Wow, those are some major filaments over there. This one here is super dense and very tall, actually. Maybe a little bit deceptive as to what's going on in the solar corona. So let's take a look at Croissant Earth here just for a quick moment to see which volcanoes are erupting. So Shivaluch continues to explode. It's a 14,000-foot ash plume, flight level 140 over Kamchatka. Subanose Jima, flight level 090 over the Ryukyu Islands. Merapi, big uptick there at Merapi as it's producing pyroclastic flows. And there's an image of Merapi erupting. That looks a little bit too close for comfort, wouldn't you say? 18,000-foot ash plume was produced by that. It's a flight level 180 over central Java, Indonesia. Semeru also exploding, flight level 140 from Semeru. So two volcanoes significantly erupting there on East Java. Popocatépetl, mild explosive activity there, no indication on the ash plume size. Fuego in Guatemala exploding, flight level 150. Nevado de Ruiz exploding, flight level 200, and not sure about Sabancaya. Please do not decide to pole vault the caldera. If you're going on a volcanic vacation, leave your vault pole at home. Next, the last 90 days of seismic activity here. No major quakes in the past 24 hours either. Let's go up the list. We'll cite quakes above a 5 magnitude. So it's a little bit of an uptick here once again. Quite a few quakes there, especially around the Pacific Rim, like this 5.5 at Fiji. That came in at 13:29 Universal Time yesterday on the 11th. And welcome to Daylight Savings Time, by the way. Daylight Savings Time now in the U.S. There was also a 5.0 at Fiji at 18:21 Universal Time. And keep in mind, folks, I say it all the time, any earthquake can be a foreshock. If you think you can forecast earthquakes, we're more than happy to listen to your hypothesis, and we would love to see that demonstrated through some actual forecasting. There was also a 5.2 at the South Sandwich Islands. That was early this morning at 1:09 Universal Time. Looks like the largest quake of the past 24 came in at 7:43 Universal Time this morning at the Solomon Islands. 5.7 magnitude quake at 7:43. So, again, remember, folks, any earthquake can be a foreshock. Have an idea which buildings might collapse. Know which building facades are, old and not built to modern earthquake code and so on. And thanks for leaving a comment and good morning, Mike Bordages. So here's the last 24 hours from SDO 171 angstroms. And don't worry, we've got lots more fantastic imagery for you here. Let's go over some stats. The 10.7 centimeter radial flux has dropped all the way down to 157 solar flux units. So way down here now. Don't expect it to stay in a dormant state, though. We got a long way to go to solar maximum. Next, our space weather enthusiast dashboard here. No geomagnetic storms or geomagnetic unrest in the forecast here by NOAA. I would tend to agree with that. There is a coronal hole high-speed stream likely on the way. I think it's going to be a pretty minor one. Let's take a look at Earth's geospace. So here's our geospace magnetosphere movie. This depicts Earth's magnetohydrodynamic pressure out to about 12 Earth diameters. It's Earth's magnetic moment from space. The units that are depicted here by the Space Weather Modeling Framework are magnetohydrodynamic pressure, known as nanopascals. So things are calm here. And I want to take a moment here to talk about ground magnetic perturbations. So we don't usually show all three of these maps. I'm going to let this one play through as we normally do. So this is 4 hours of global ground magnetic perturbations. Geospace delta B means changes to Earth's B field, the field that goes through the magnet, that magnet being the Earth. And this will show you the most likely places to see telluric currents, pipeline, railway, and power grid induction, and also the aurorae. So the other available imagery you can view there is at the poles, which is always nice, especially during geomagnetic storm conditions. It'll show you the most likely places to see the aurorae, but I wanted to actually show the least viewed of the ground magnetic perturbations map. And this is all Tamitha Scove's fault, so if you don't like it, you can blame her. Let me actually shrink that down so the whole thing can be viewed. There we go. So this is just a fantastic map here, folks, and this coincides with other data sets. So again, that's going to show you the most likely places to see the aurorae and so on. And it's greater detail than those other maps. So we will be showing this in the future, especially during times of geomagnetic storm and geomagnetic unrest. So check that out, and also make sure you check out Space Weather Woman. If you haven't seen it, Tamitha Scove is one of the most knowledgeable people in the world about space weather. Her job is, well, satellite maintenance. She's also doing things like testing materials for space flight and so on. So check out spaceweatherwoman.com and check her out on YouTube. Yesterday we spent a solid couple of hours in her Q&A mini course, E4, Space Weather Effects at Ground Level. So if you want to hear about what space weather can and can't do, try watching this video. It's got some great insight into the physics of power line induction and so forth. Tamitha's great. She's got a great sense of humor, and she even reacts very well to my most snarky comments. Going back a couple of years there, giving her a hard time for not putting out daily space weather content videos. Thank goodness she's not a competitor to us, because she would, well, she blows us out of the water. Anyway, here is our planetary K-index. That's a measurement of a global geomagnetism. That's from ground-based magnetometers, by the way, if you're wondering. And we have geomagnetically calm conditions here. 2.67 is the current KP index. Let's take a look at the real-time solar wind measured out here at Lagrangian point 1, a million miles from Earth or so. By the ACE and Discover, if all things are working according to plan, and it looks like they are. So current conditions are just under 12 protons per cubic centimeter for the solar wind density. Solar wind speed here, 381 kilometers per second. We also have recently seen some shifts in both the solar wind plasma temperature and also the magnetic field. So if you look at the top pane there, the field's weakened and went into the positive territory there. And the plasma temperature dropped at the same time that the solar wind speed dropped and the density came up. So that could be actually a weak coronal hole wind stream. I wouldn't be surprised at all to see the density drop off and the velocity increase. So stay tuned to the real-time solar wind to see if I was right on that forecast. Next, looking at magnetic data. These are our GOES magnetometers. They measure Earth's magnetic field from space. So they are at geosynchronous near equatorial orbits, the GOES 16 and GOES 18. And we are seeing some spikes there in the most recent data. Could be an indication that a coronal hole high-speed stream is showing up. And if we do see a coronal hole high-speed stream, you can expect to see that get all sawtoothed. A lot less smooth when we see coronal hole wind stream impacts as magnetohydrodynamic waves propagate through the Earth magnetosphere. Next, let's take a look at the heliosphere. This is the heliospheric current sheet. And at the moment, Earth is moving right toward the middle of a North Pole current sheet depicted here in green. South Pole current sheet depicted there in red. And once EpicPen responds to my commands, I'm going to move on to our line of sight field plot. So there's the Sun's B field depicted in blue, north and south solar polar fields depicted in green and red respectively, which brings us to coronal holes. And we've got some North Pole oriented ones visible currently on the Earth-facing portion of the solar disk. Namely this one here and this one down here. So if we look at 211 angstroms for the past 24 hours, you'll see those pretty well defined in this wavelength. Which brings us to sunspots, which again, sunspot number has decreased along with the radio flux since yesterday. So reduction in sunspots there, reduction in flaring, and less 10.7 centimeter radio flux, so less flux density there for the 10.7. So that's the current situation. Let's take a look at it from SDO's perspective. Here's SDO continuum plus 94 angstroms to show you the bright spots. So it looks like the activity at the moment here is primarily in the southern hemisphere and up here in the northeast. So these groups down here are producing some activity, and also this northeastern limb. Here's a closer zoom in. 94 angstroms shows the flares, and the SDO continuum shows the sunspots. Let's drop the 94 angstroms. So most of those groups have been stable for the past 24 hours. Some rapid formation and degradation there in the southern hemisphere, but besides that, a slight reduction there in sunspot number and radio flux. Continuing on to energetic particles and solar flares, we ain't got none. At least no energetic particles there. No spikes in the proton flux. No solar energetic particle events, or SEPs, occurring in the past 3 days, or the past week or so, for that matter. And next, looking at the GOES X-ray flux here, again, we have seen the background radiation drop down to a high-level B class. So we've only had some C-class intensifications in the past 24 hours. Largest flare was this C3.2, which occurred this morning at 7:20 Universal Time. And here's a great wavelength to view flares, 131 angstroms. It takes 10 images per minute instead of only 2. Next, we'll take a look at some astrography. Yeah. Analyzing our location and the location of other things. So this is what's going on overhead at the moment, Lehigh Valley, Pennsylvania. The moon is setting over there, just south of the ecliptic. You've got Mercury, Saturn, Jupiter, Venus, and the closest star all up there above the horizon. Here's where things are located in the solar system. Keep in mind that this imagery is not to scale. These things are very, very far apart. We'll advance this 1 week. It's our 1 week solar system forecast. There's where we'll be in a week on the 19th of March as another new moon is on the way. So here is our coronagraph imagery, doing some analysis of those coronal mass ejections to find that they are not likely earthly directed. You'll see one just starting to propagate there in the northeast, right at the end of this series of 106 frames, because these are daily. So let's move to the today, and there you can see a second CME there in the northeast, also not earthly directed. You want further corroboration? Okay, let's take a look at the view from stereo A, since it includes additional fireworks. So there's some more spectacular imagery from stereo A and the Soho Lasco C3, a Phoenix-like CME happening there from the northeast. So that's just some great imagery for you. We'll let those play all the way through and then show you some additional 24-hour videos. And more coronal mass ejections are very likely. We'll tell you why here in just a minute. Again, like I said, it's a special Sunday edition here, as we've got a lot of fantastic imagery to show you. So that's what's going on. Hopefully you find it illuminating. And again, check the links below the video to the Red Bubble Shop. I would say to each of you, Universum Liberate. So that's the past 24 hours from SDO 193 angstroms, the Soho Lasco C2 and C3, and also Mercury showing up there on the frame. DAG. Here's a little closer zoom in there as Mercury peeks in on the lower right. And how about an even closer view? A very dense core there was emitted. So that CME, that's the Nikki Haley filament. It was named by one of our viewers. And of course, keep in mind, folks, we have no political affiliation. This is an apolitical channel. Never been associated with a political party and likely never will. Maybe if they decide to salary us. Just kidding, folks. Anyway, this is the reason why you can expect to see additional coronal mass ejections, because we've got a massive number of filaments, and some of them are looking quite unstable. So you've got this prominence down here, you've got this prominence up here, you've got this huge filament here, filament over here, filaments, 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 filaments. This might be the most we've ever covered on the channel, and we're pushing 6 years of daily space weather videos, so those are a lot of filaments. So if you've got a filament you'd like to name, keep in mind some of these are already named. Let's bring up the latest image here just to go over this briefly. So here you've got, let me play that again. Hold on a minute. Okay, so the rest of the Nikki Haley filament is largely set. You can see it right there. That's still the Nikki Haley filament. Most of that ejected yesterday. This here is the Brian Keating filament. This one up here is the Barack Obama filament. And this one was named the King Charles. That might actually be this filament here, as it is now not really a prominence anymore. But if you'd like to name filaments after living people, make sure you join us on Twitter. Just follow the hashtag #NameThatFilament, as they are kind of an important part of space weather. Of course, we discovered a few years ago that we could forecast coronal mass ejections. We just don't really have any incentive to do so. So it's not something that we do on the regs on the channel. Again, follow us on Twitter. Thanks to our Twitter followers, we've lost a follower since yesterday, which is no surprise at all. Continuing on to some more 24-hour imagery here. This is SDO 304 angstroms. You can also see a great prominence here associated with that northeastern coronal mass ejection yesterday. There's a great prominence, partial filamentary collapse happening up there. Once again, here's what's going on in the southeast. And whoops, there goes the Nikki Haley filament, ejecting and part of it also collapsing as it sets over the north of the southwestern limb. Yowzers. So those are, once again, all 24-hour videos, folks. And here's the past couple of hours from the GO 16 SUVi. So this is what we typically stream live on the Twitch channel. And of course, we streamed it yesterday, and what is up with that? There we go. It looks like it's working. So just pay attention to the time and date stamps. Again, that's a different time frame. That's just a couple of hours there. That's 2.5 hours, I believe. 10 o'clock. It's like about 10 o'clock to about 11. I don't know. 10 o'clock to about 1 p.m. Anyway, let's continue on here. It's time for bonus features. Let's see what's going on as far as satellite charging hazards. That gives us some insight into space weather, and there are some surface charging hazards here forming over the Central Pacific. Next, the GOES electron flux. There you go. That's the past 3 days. The GOES 16 and GOES 18's radiographic measurements. So they measure the electron flux using radiography from their very high geosynchronous orbits. They measure that at the F layer of the ionosphere. Some indications that a coronal hole high-speed stream is showing up here. Density wave first, as is normal. There's the forecast model for the electron flux. And I would expect a dip here also. So no arguments from me there. That's NOAA's forecast. The green boxes, the yellow diamonds are the observation. Here's the 1-year graph to put that in context, to give you an idea of where we are, kind of in the middle upper part of the operating range there for relativistic electrons. Next, the F layer. We'll show you the ionogram of that. That's the upper layer of the ionosphere, located at about 300 kilometers of altitude. Here's the vibrational frequency and also the anomalygram. Well, we're seeing major high-frequency anomalies happening in the southern hemisphere once again, especially. So keep in mind it is still summer down there, and keep in mind March is a very geomagnetically active month. I think it's the second most geomagnetically active month on the planet. And it probably has to do with the angle of Earth's magnetic field with respect to the incoming solar protons. It has a tendency to, probably because it's more perpendicular, so it's got a higher amount of Bremsstrahlung that happens there. In other words, there's a greater amount of braking radiation that happens around the equinoxes. It has to do with the angle of attack of Earth's magnetic field lines versus solar protons, the solar wind. Anyway, that's what it does, is it accelerates the electrons in the outer Van Allen belt to attempt to reach static equilibrium, of course. Anyway, you may see some major anomalies on this map if you're used to looking at it. If not, don't worry, we'll show you the anomalygram. So here's the anomalygram. Anomaly in megahertz from a 30-day median, and we're seeing wild swings there in the ionosphere, especially over the southern Atlantic Ocean and the South American continent. So that's pretty bonkers right there. You see these wild shifts from high to low frequency anomaly, especially in the South Atlantic. So those are huge changes to the ionosphere happening there, and lots of high frequency anomalies as well. So major anomalies there on the ionosphere map. I believe the ionosphere map appeared on yesterday's thumbnail. So anyway, there's the latest image, 1245 universal time ionogram, and there's 1245 universal time anomalygram. That's anomaly in megahertz from the 30-day median. Megahertz are millions of vibrations per second. We'll also show the total electron content forecast. The free electrons between your GPS satellite and your handset, a run of about 12,500 miles. The total electron content forecast is the coupled thermosphere, ionosphere, plasmasphere electrodynamics model. And free electrons will cause signal refraction, aka GPS errors. So things are pretty organized here actually at the moment. Nothing too out of the ordinary. This might get very jiggy if indeed we are seeing a coronal hole high-speed stream impact. So it's showing up a little earlier than perhaps expected there. But at the moment here, the total electron content looking pretty normal. Most GPS errors there occurring around the equator at noontime. We've reached the end of our space weather portion of today's video, where we're going to show you the latest on the intensitygram and colorized magnetogram. Again, things have degraded since yesterday, so less sunspots, lower radio flux, and flaring kind of low. Keep in mind there are some players, especially in the southern hemisphere, that certainly do pose the possibility of producing large flares, like this group right here. It's certainly got complex magnetic fields. It looks a little more exciting in magnetogram than it does in intensitygram. Also, this group over here looks promising. Some interesting beta-gamma class sunspot groups there. Especially this group down here. This group is looking a little unstable. There's your full disk rock back. And it's time to go to meteorology here. So, I mean, that's kind of how I got the start in space weather, by the way. I realized that forecasting the weather is way too easy. And as a pro cyclist, I realized that I need to be able to forecast the weather because I want to know if it's going to be raining at the beginning, middle, and end of my bike ride. So, I mean, I've done stuff like forecast the weather on one side of the mountain and the other to stay dry and avoid summertime rainstorms. It's not challenging enough. So we decided to include meteorology in the videos despite needing greater challenges, aka space weather. So an important factor of space weather is the seasons, of course. Again, the Earth is more geomagnetically active around the equinoxes, so we're excited about that. We've barely got a week left of winter, and we will be streaming live on YouTube at March 20th. We'll start at about 5 p.m. Eastern Time, and we're located in Lehigh Valley, Pennsylvania. If you want to support the channel, consider becoming a member of the Smash Team at smashomash.com/Smash Team. There's a gold, a silver, and a gold annual paid-up subscription level. We are in the process of composing a paper proposing a likely plausible mechanism underlying the solar sunspot cycles. When it passes peer review, it'll be, shall we say, kind of important. So assist us with that, as we do need your assistance to incentivize us to continue creating these videos and continue with everything else that we do at smashomash.com. So thanks to everybody who supported the channel. And there are also email alerts that get sent out for natural disasters and for other things like when we post videos. Click the posts page after you've logged in. There's also a bronze level, which does indeed receive email alerts. So let's move on here to our meteorological segment. We're starting things out here looking at Earth's rectal thermometer. Yeah. So that's what's going on in terms of sea surface temperatures. Let me press refresh there, as it doesn't look like it's animated. All right, so you're looking at sea surface temperature anomalies there, and the moving portion, those are ocean currents. So currents and sea surface temperature. So that's what's going on in the Southern Ocean. There is the Atlantic. Let's zoom out. There's the Atlantic. There is Earth's largest surface heat sink, the largest body of water on the planet, the Pacific Ocean. And you can see La Nina is breaking up here as this equatorial anomalously cold water is slowly warming up. So that's probably great news for most meteorologists here, as the La Nina weather system will likely end as many forecasted. Anyway, there's the Indian Ocean, by the way. There's the Arctic. Let's take a brief look at the Gulf Stream, since there are probably some YouTube channels that are still saying that, oh no, Europe is going to have a year without a summer because the Gulf Stream is going to shut down. Except, there it is. It's not shutting down. It's still warming up Ireland and Iceland. So, year without a summer canceled, along with your grand solar minimum. Not a thing. The water is anomalously warm up there. Look at that. 16 degrees above normal there. Due east off the coast of Long Island and Cape Cod. Yeah, Cape Cod. All right, let's get to our normally scheduled content here. We don't want the video to be too lengthy. These are the surface winds of the eastern world. How about the jet streams? There you go. Jet streams. The jet stream of the Pacific Ocean is pumping way too much moisture into California, as you can see. And that warming of the equatorial Pacific is probably creating additional convection, which is really not good news for California, at least at the moment. I think the drought might be over. What do you say? There are the jet streams over the western world, and here are the surface winds. Still got several strong lows there in the northern Atlantic. These are the surface winds of the central world, Europe, Africa, and the Middle East. And like sands through the hourglass of time, these are the jet streams of our lives. How about clouds and fog over the Americas? Yeah, here's Croissant Earth being projected onto a fake Adobe Photoshop sphere. NASA, they're really incentivized for you to believe that the planet is spherical. Just kidding, folks. Spherical Earth is over 2,000 years old. The ancient Romans accurately calculated the diameter of the spherical planet, if you're wondering. Croissant Earth. Don't believe NASA's lies. Next, our weather.gov map. There you go. There's your weather.gov map. We've got some winter storm conditions forecasted for the Northeast. So winter storm watches happening there. If your location's lit, click your location. A few too many counties with weather alerts for us to cover there at weather.gov. So here are some forecasts, and guess what? Portions of California are forecasting 6-7 inches of rain there for portions of California. That looks suboptimal, as it is already quite moist. That's our GFS 72-hour total accumulated precipitation forecast in inches. And that is going to cause additional shocking flooding, especially in northeastern California. Here is our pressure and precipitation forecast based on the same model, the 72-hour GFS model. You can see that low is going to hang out there. It's going to kind of circle around and sort of reform there right off the coast of Cape Cod. So that'll make some extended weather conditions, especially in New England, places like Connecticut and Massachusetts. And here's your GFS 72-hour accumulated positive snow depth change in inches. Some heavy snows there forecasted for Massachusetts, New York, Vermont, New Hampshire. And much heavier snows forecasted for California. Check it out. More snow there. Another 2+ feet forecasted there. Let's show the difference between the GFS and the Euro model for the next 3 days of snow. There is new snow on Witty.com. That's your Euro model. There is the GFS model. The Euro model forecasting a lot more snow farther south in Texas than the GFS model, for example. Again, there's the GFS. There's the European model. That's new snow for the next 3 days. We've also got a lightning mapper. Some significant lightning there. Coming across Arkansas, Louisiana, Mississippi, Alabama, moving into Georgia, and so on. Let's see if we have any current terrestrial strikes. We did when we did show prep. Looks like things might have calmed down a bit here. Give it a moment to load at lightningmaps.org. And it looks like we indeed do have some terrestrial strikes here. Right near the Homochitto National Forest. Actually in the Homochitto National Forest. Hamachito? I don't know how it's pronounced. Those doggone Native American... Wait, what are they called? Original Americans, I'm supposed to say now? And south of Atlanta, we've got some active cells as well. Oh my God, I've moved things around. Dear God, what have I done? All right, what do we have here? This is the Charlie Elliott Wildlife Center. Anyway, those are your active terrestrial cells. We'll show you the full global map there. Looks like some lightning occurring in Saudi Arabia as well. Also around southern Italy. All right, continuing on here to our U.S. Doppler radar map. There's the full 50 state view. Here's the lower 48 view. Pittsburgh getting some precipitation. And things are clearing up in Columbus. The heaviest stuff is over places like Mississippi and Alabama. And a great view of this rotating low here. That's clouds and fog, 3.9 nanometer infrared radiation, and there is water vapor. So we do have a bit of an impulse here. There is some cold air moving in, kind of like this. And that's going to create like a blocking feature, preventing this moisture from moving very far north. And it's going to smash it into this high pressure zone. So this is going to act like a wall, another blocking feature there, and that's going to steer that moisture straight to New England. Hopefully that helps. Hopefully our channel helps you understand atmospheric physics, and hopefully you're able to forecast your own weather. Drop us a line if you'd like a personal forecast for your location. Leave us a comment about that, and we'll be happy to consider giving you a specific forecast. And there is the water vapor map. If your Doppler is not giving you the info you need, try the water vapor map. It should help. Hopefully the Smash News Network, least busted name in news, helped you to understand space weather and Earth weather. We'll see you soon. In the meantime, I'll have been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back. Please don't forget to visit the links here and here and here.